Properties of matter. Use this section if you need to know chemical and physical properties and chemical and physical changes. All right, ladies and gentlemen, properties of matter. It's a characteristic that identifies a substance. It's used to identify the substance so we can separate them into mixtures, or we know what it's going to react with if we know the properties. How are you going to remove iron filings from sand? Iron filings can be removed from sand because iron has a specific property called magnetism. Iron and sulfur, when they're physically mixed as a mixture, and I could separate them, but iron and sulfur, if it's chemically mixed, let's see what happens later. All right, how are you going to remove salt from water? The only way to remove salt from water is by making the water evaporate, because salt dissolves in the water, so there's no way to take that salt out unless you remove the water from evaporation. There are two types of properties. There's a physical property, and there's also a chemical property. Physical property identifies the substance without changing its chemical composition. So you can color something. It has a specific odor that tells you what it is. Its phase, a solid, liquid, or gas. Aluminum has a density of 2.7. Water has a density of 1.0. Each density is a characteristic property that helps you identify what the substance is. If you know that it has solubility, you might be able to figure out what the substance is. You also know it's conductive, you know it's a metal. You know that if it's not conductive, it's a non-metal. So these characteristics can help you identify the substance. Hardness, that means can I scratch it? If it's soft, you know that the hardness is low. If you can't scratch it, then the hardness is high. Boiling and freezing point. Each substance has a specific point at which it boils and freezes. So all of these characteristics help you identify the substance, but when you're testing them, you're not changing anything about it. So when you're smelling the odor, you're doing nothing. You're just smelling the odor. And that's a physical property. When you're looking at its color, you're doing nothing to it. You're just looking at its color. When you're measuring its density and you measure its mass and volume, you don't change what it is. When you measure its conductivity, don't change what it is. So all of these things, if you test them, will not change the identity of the substance. So these four liquids right here could be the same. You test them out. They have different colors. Smell them. Are they the same? They're all liquids of the same phase. Just test their densities. If they have different densities, then you know they're different. Something dissolved in them. You can also taste them. You can check to see when they boil and when they freeze, and then you can identify that they are different. Chemical properties. Chemical properties are very different because the chemical property actually causes a reaction. So when you're testing for chemical properties, you actually change what you have. So if you're testing to see if it's flammable, and you take a piece of wood and you put fire on it, you put heat to it and it burns up, well, you're not going to have the wood anymore. So any chemical property test will actually change the substance. If you check to see if it reacts with acid, limestone will fizz when acid is added to it. That's how we get our caves. So you know that if it reacts with acid, it's a specific type of substance. Quartz will not react with acid. So if you have two things that look similar and you test them with acid, you can figure out what it is. How does it react with water? Does it dissolve in water, or does it make carbon dioxide? Does the water break up that compound? If it has a reactivity with water, you know that it could be certain substances like sodium and water make an explosion. How does it react with oxygen? Does oxygen make it burn or rust? If it does that, you know that it has a chemical reaction. How does it react with other elements? If it doesn't react with anything, well, right away you know though it's one of the noble gases. So when you're testing for chemical properties, you're going to test all these things out and eliminate what it is. You're like a detective. So on this date, we did some demonstrations. On lucid paper, you made a chart, physical and chemical. So we did like cutting paper. Cutting paper would be physical, but if I burnt the paper, that would be chemical because I changed the substance. We also did elephant toothpaste. So elephant toothpaste is a chemical reaction. So you see the differences. And we also melted ice. What happens to the chemical composition of ice when we melt it? Ice is H2O as a solid. If I melt it and become H2O as a liquid, did I change the chemical bonds? Did I make anything new? Nope, it's still H2O. It's just in a different phase. So therefore, is this chemical or physical change? This change from solid to liquid melting would be a physical change. So what actually happened? The H2O2 in the elephant toothpaste, which was a peroxide, which was a liquid, broke apart. This becomes H2O as a liquid and O2 as a gas. So we took these chemical bonds and we broke them apart. Is that a chemical or a physical change? This is going to be a chemical change because we get something new. The hydrogen peroxide is broken apart into water and gas. Did we break the law? Did we break the law of conservation? Well, let's see. How many hydrogens on this side? We have 4, and we have 4 on that side. How many oxygens on this side? We have 4. 2 times 2 is 4. Here we have 2, and here we have 2. So whatever started with the reactants equal the products, so we didn't break the conservation of mass or matter law. All we did was rearrange the atoms and form new compounds. Therefore, this is a chemical change. Which one of these is a physical property? Melting ice. This really should say which one is a physical change. If I melt ice into a liquid, or if I break down hydrogen peroxide into water and gas, which one is physical? Which one doesn't change the arrangement of the atoms or the compounds? Just the first one, melting ice. All right. Changing matter continued. If I change matter, I can't destroy it. I can't create anything new. I conserve it. So what's on one side is on the other side. Conservation of matter can be physical or it can also be chemical. Changing shape, changing volume, or changing phase. We don't get a new compound. We don't get anything new. The properties stay the same. So cutting, melting, tearing, or testing its conductivity is all physical. Chemical change is different though. Chemical change means the chemical composition has changed. All the atoms are the same, but they're just rearranged into a new compound. So if you burn wood, if you make milk sour, if you rust something, if you're digesting your food, or you're having something react, we have a new substance. This rust is ferrous oxide. It's not iron anymore. It changed. It chemically combined with the oxygen and made something new. This burned and broke apart the carbohydrate of the wood. So a mixture of hydrogen and oxygen, when we add heat to it, we add a lot of energy, they chemically combine and make water. So you notice that these two elements change to make something new. That's a new substance. So this concludes the chemical and physical change portion of your notes. All right, let's go over this. Let's see if you know it. Physical. Painting a fence, is that physical or chemical? That is definitely physical. Digesting a banana, is that chemical or physical? That's going to be chemical. Why? Because now the banana is no longer banana. It comes out differently. You break apart the bonds and you use the piece of the banana in your stomach, your small intestines, and gets delivered to all your cells. You don't deliver bananas to your cells. You deliver smaller molecules that are differently arranged. I chop wood. Still going to be wood. Physical. Burn the wood. I don't have wood anymore. Now I have carbon and I have gas. Rusting. I don't have iron anymore. Now I have ferrous oxide, which is a chemical combination of iron and oxygen. Milk that sours. I don't want to drink that. That's going to be a chemical change. And reactivity is going to be a chemical change. All right, let's see what we got. How is a compound different from a mixture? Next